Hello everybody. In this video we are going to talk about one nice thing that we need in many cases, which is extracting data from graphs. So let's say we have a graph like this. This is a relation between any two parameters, no matter what parameters that we are talking about. But we have the x-axis, we have the y-axis, and we have this graph that represents the relation between these two parameters. In many cases, we have the graph either getting it from a textbook, from a reference, from the internet, whatever the place that we get it. So we get it as a figure or an image, and we do not have the raw data or the XY data that were originally used to plot this graph. And in many cases, like what we did in the previous video when we wanted to find the cost of the pump from the graph, which was this graph. So we were interested in extracting the data so that we can fit the data and find an equation that can describe this graph so that we can use it in our calculations. So this is something that we are interested in, and there are many other cases that we might need to get these values. So one way we can think of this is to do it manually by like taking any random points. Let's say I'll take this point. It looks like it's around 5 and 4.5. This is something like 9 and 6.4, whatever the values that you think it is. But this is going to be a very time consuming process, and it's not going to give accurate results. And that's why we cannot rely on this method in getting the data. So what we are going to do is to see a software that can help us with this task and can do it for us. And there are many software that can do this, but the one that I used is called WebPlotDigitizer. If you just type WebPlotDigitizer on Google, just without spaces, it's WebPlotDigitizer as a single word. You'll find that it's a pretty famous software. I have used other software. One was called XY Extract, and I think there are a bunch of softwares that do the same thing, but this is kind of the most famous one of them. Anyway, so this is, it says extract data from plots, images, and maps. When you open this link, you would see that it gives you an option to download the software. So you can do it like download it either for Windows, for Apple, or for, I think this is Ubuntu, whatever the operating system that you're working with. You can download the software and install it. When you download the software, by the way, you do not need to install it, so it's not an installation process. You just need to open this icon, and it's gonna open everything. So there is no an installation process is not needed in this case. One other option is to use it online. I think it's here. Yeah, it's a web-based tool. You can either use it as a software or a web-based tool. So in this case, you are gonna use the software online without the need of installing the software. Both are going to be exactly the same. This is exactly the same thing that we're going to see when we use the installed software or the downloaded software. So whatever the thing that you want to use, it's going to be fine. I'm going to open it here from this icon. I personally, because I use it a lot, I created a shortcut for the software so that I can easily use it. It's on the desktop, and I put it here in the list of my files here, which is here. And by the way, if you want to do this, just right click here, and you can do send it to I'm not sure where I did it, but yeah, you can pin it from start. It's here unpinned, but you can pin it from start, or pin it to start menu. Anyway, so this is the software, and this is how it looks online, and this is how it looks when you download the software. So exactly the same thing. So you do not need to worry about anything about it. Now let's see how can I start the software. And before I start, I just want the audiences to be aware of what the steps that we're gonna go through. So the steps will start with defining the coordinates. So I have to tell the software where are the coordinates, and this is because the software does not understand that this is a graph and does not understand where is the x-axis, doesn't understand where is the y-axis. So I have to define them in the very beginning, so that the because for the software it's just a group of pixels, and it can extract the data, and from the data and from the coordinates that I have defined in the very beginning, it can tell what the coordinates of a specific point is. So the first thing is to load an image, but first there are some like some things here on the left part of the window, and there are some things here on the right part of the window. So this is what we are doing, like the big title, and these are the options that I can use. So here I have an image that is the default image that's open. You can use it, or you can use any other image if you want. Here you can have options related to axes. Here is the like options related to database and the measurements, and we're gonna go through like most of them now. So the first thing is to, there are some tutorials here, you can find a lot of them online, and they might have more information than what I'm gonna present in this video. So this is a very good resource for you if you are interested. So what I'm gonna do is to first load image, and I'm gonna choose the file. I'm gonna go for this first, and it's opening the file now. So this is the same image as this. You have the option to consider this image as a 2D image, an XY plot, or a 2D bar plot, or polar diagram, ternary diagram, map, or an image. So I'm gonna consider it as a 2D plot, and the first step is to align axes. Here it tells me that I have to do or choose 4 points, 2 on x-axis and 2 for y-axis, and the software will use these points to define the x-axis and the y-axis. And you can see here that they don't have to start from the origin. They will start wherever the place, and the software can take care of everything after that. You have to make sure that you follow this sequence. The first is the minimum x, then the maximum x, the minimum y, and the maximum y. And I'm now gonna proceed. When you move the mouse over the image, you see that there is an like a zoom in part here, so it tells you exactly where you are in a very precise way. So let's say I'm gonna start the x1 from here. So I'm kind of trying to adjust it as much as I can. So this is x1, and this is x2. Don't forget the sequence, and then y1. Of course, the grid lines really help in this case because it can give you like an easy way to determine the point. And this is y2. Let's say I want to kind of fine-tune the location. This like needs to go a little up, for instance. So you just click on it, and with the arrows on the keyboard, you can move up, right, left, whatever the thing, and you can do it for all of them until you are happy with what you have. And once you're done, you can click on the button complete. So now the software is asking you what do these points represent. So x1 corresponds to the value of 10, x2 corresponds to the value of 100, y1 corresponds to 2.5, y2 corresponds to 6. So these are these 2 points, these are these 2 points. If you are working with an image that, or a graph that has a log scale, you can choose which is a log scale. Once we're done, we can click OK, and you can see now the part of the image is done, and the part of the axis is done. You can go back to this. So if you click on the axis, you can either rename it. You can give it a name if you want. It has the default name XY, but let's say axis 1. And if you want to tweak the calibration, it's going to open this calibration for you again, and you can choose to recalibrate them. So I'm not going to do anything about it. And now let's go to the dataset. So the dataset is the place where the points or the data are going to be saved. You have here this dataset, and it's giving you some options either to rename the dataset. So I'm going to call it set number 1. and you can delete it, you can edit the point group. I don't have any points here, so it's not the point now. You can view data or clear data. And for this you can choose what type of axes that you want to use to define the data. So let's say for some reason you have more than like a set of axes. Let's say you have a primary y-axis and a secondary y-axis, and in this case you can define more than one axis, and with two different y values. So in this case you can define a set or data set for the first part and or for the primary axis, and a data set for or axis for a data set for the secondary axis or the secondary graph. Anyway, so we have here the like a color to display. You can it's kind of like something that you can play with. You can choose any kind of color that represents this set, so that you can distinguish between the different sets. Anyway, so this is the set one where I'm gonna save the data, and now we will go to the important part. Oops, I need to clear this. The important part here is how do I extract the data from the graph. And to do this, we have first to know that there are two modes, either to work for the manual extraction, which is going to be the topic of the next video, or to go for the automatic extraction. Automatic extraction means that the software will automatically do the job for you. It's gonna find the points, give you the coordinates, and do everything for you. So we have here like some options in the automatic extraction, and let's just put it first that the software can do the automatic extraction when it's possible for it to do it. So in a case like ours, we have here only one data set, and this data set has red color with white background and black grid lines and black X and Y axes. In this case, it's so easy for the software to know where the graph is, and doesn't get confused with the background or with the other things here, the grid lines or the like the text that in the figure. And in this case, we need to tell the software that you are gonna look for the red lines, and here what it says, the foreground color. I'm gonna choose either to choose the red color, or you can do the color picker. You just click here and it extracts the color, and the color is defined by three values: the red, green, and blue. And the maximum value is 225, and because it's like reddish color, so it's like very or a big value of R and small values for G and B. Once we're done with this, it's okay, and just make sure, like, keep in mind that we have values for these. So when I'm done, it knows that this is the foreground color. If you have a background color which is white, so if you have a different color, you can choose it. And now for this distance, this distance means that you can have kind of tolerance in defining the colors. So we have the color, as we mentioned here, it's like 200 something, 44 and 29. So you can, if you have a color that is close to this with a small difference in the values of R and G and B, it can consider it the same data set, or it can ignore it based on the distance. This is kind of tolerance thing. You can increase it or decrease it based on what the case is. And then the averaging algorithm is how the algorithm that's here is how the software can go from a point to another. So I don't understand how they do, but this is kind of some mathematical methods that can be used to define how the delta x and delta y will be calculated, which are the distance between each 2 points. So let's say I have a point that is defined here, and it's gonna look for another point. So to get the other point, it has to look with a distance of 10 pixels from horizontal and vertical direction. So this is how the points will be calculated. There are other things here, but I'm gonna keep them for like few minutes. I'm gonna talk about this in a few minutes. And now we're done. I have defined the foreground color, I have defined the axes, and I have defined the delta x and delta y, and I'm gonna run the thing here, and you see it's all these are points. and it says that it has extracted 2,916 points, which might be good, but it might be too much. And in this specific case, because the line was wide, it's not good at all, because you see here, it looks like the octopus leg now. It has a lot of like circles in the same spot. And this is because the delta x is very small and delta y is very small, and because the image is a big image. Like the size of image is big, so 10 pixels is very small thing here, and the line is thick, so there are kind of combinations of many things. So in such case, it's better to go for like 30 or 40 delta x and delta y 40 pixels, and I'm gonna run it one more time. You see the number here will get smaller, 396, and you don't have any overlapping here. The points are like a lot of points, like like very good to define the graph very well. So if you take these points and plot them, it's gonna be like more than enough. So this delta x and delta y will have like a very good, like very big impact on the numbers of points that you have on the graph. Now let's say I'm done, and I want to use the data. So what I'm gonna do now is to view data, and here it gives you like a list of all the data points that you have. And you have an option of two, which is first to copy the data to clipboard, and in this case you just open any Excel file, and I have them copied now to the clipboard, and I'm gonna paste them in the Excel file. I'm just waiting for Microsoft Excel to open, and then we will see, or paste the values in there. Okay, so now this is Microsoft Excel, and what I'm gonna do now is to just paste. So we have the values here. There are a lot of values, so we need, and they are like values separated by commas. So I can use the text to column option to separate this into two columns. Each one of them is like specific values or a specific number. So this is one thing that we can do, or you can download it as CSV file. And in this case, let's just save it in the same place. And this is the new Excel file that has the data, and you see it's gonna be exactly like what we did, the same thing. This is the manually copied, and this is the automatically generated or exported values. So both will do the same thing. Either you would go for this or this, it's gonna do the same job. Okay, so now let's see if we have like some other thing. If I'm interested in a part of the image, so I'm gonna create a new data set. I'm gonna call it set2, and add single database. So now I have two bases here, and let's say I have a new, like I'm interested in part of the image. So here comes the part of the mask. So I can draw a mask here, like a square or a box, and again define the foreground color and the background color, and this is what I need to do. And I'm gonna keep it as 40 as we did last time. And in this case, when I click run, it's gonna extract data from only this part. So I'm clicking run, and you see this is the part that is extracted. It's only 53 data points. And when I click on view data, I have the option either to see set1 or to see set2, and both are available for me to download if I want. One last thing is that I can draw instead of having a box, I can draw lines. So I have this, so I can draw line here using this pen. I can make the pen thinner, thicker, whatever the shape I want. This is something that I can do. Again, I can run and view the data, so this part will be included this time. So the mask is very nice because it gives me an option to see or extract points, not on the whole thing, but just in part of it. So this is all for this video. In the next video, we'll see in like cases that automatic extraction is not gonna work, how we can do extraction. So I'll see you then, inshallah. Goodbye.